first section, section A, chapter 1. So the appeal to emotion. So here's the argument. Thousands of unarmed people, so let me highlight where I am here, right here. Thousands of unarmed people, many of the children are killed by firearms every year. It's time we ban the sale of guns. So the first question is, what is the premise of the argument? So you can tell me which of these options here is the premise of the argument. Yes, please. Thousands of unarmed people, many of which are killed by firearms every year. Okay, the premise of an argument, that is a statement that is data. It's data, it's information that you're using as a structure, a building block to build up your argument and lead to a conclusion. And so it's asking what's the premise. It's just saying what is information that's being given to you. What are the pieces of information? Yes.
Would it be A, thousands of unarmed people? What?
Well, I mean, there's not that much wrong with that answer, actually. It's just this. I would say B is better because it's very specifically the sentence they're using. It's exactly the piece of information.
I would say.
And also, it's critical to how they're going to reason that many of them children. That is the thing that's mostly making an appeal to your emotion. Because we need our heartless passion. People were killed, okay, who cares? Children, no. Think of the children. That's why politicians all say, think of the children. Think of the children. That's why they do this, it's appeal to emotion. They don't ever say, think of the people killed. Well, some do. Some specifically don't, right? Some don't say, think of the people killed. Think of the children. It's an appeal to emotion. So I would say B is a better answer here because it's what is actually stated by the person in their argument as a data point, as a piece of information leading to the conclusion. So for that reason, I would say B is a better answer. But A is certainly not a very bad answer. I don't know how this thing breaks it. It is possible to get partial credit on this, but I don't want to get the wrong answer on this. So I want to try it. You can try it. The grade matters nothing with this. So you can try it and see what it says. What's the conclusion for this argument? That's this question. What is the conclusion? I'll read the novice. Maybe it's more beneficial. Is the conclusion thousands of unarmed people, many of them children, are killed by firearms every year? We know the answer is no, right? It's not that one. Is the conclusion thousands of unarmed people are killed by firearms every year? Well, that's just part of the premise of probably. We should consider restrictions on gun ownership. Well, the person literally never said anything like that. So that's not anything. So it has to be by a process of elimination last. It's time we ban the sale of guns. Okay, now this multiple choice thing on your actual exam, I'm not going to put a multiple choice like that. I'm just going to ask you, what's the premise, what's the conclusion? And you just write them. Just quote them. Just quote them. Here's the premise. It's obvious what the premise is. Just quote them. And it's obvious what the conclusion is. Just quote them. What the conclusion is for that argument. Okay, so we get to the next one. Briefly describe how appeal to emotion occurs in the argument. Choose the correct answer below. Also, I'm not going to be as strict as multiple choice giving you sort of halfway correct answers. I'm just going to ask you, in what way does it do this fallacy? In what way does it do that? Just describe it. How is it this fallacy? And it should be clear. You can describe that how emotion occurs in the argument. One option is the conclusion is stated as if it was the only possible conclusion. Is that what appeal to emotion tells us? I mean, it's true that it states as if it's the only conclusion, but that's not what the fallacy of appeal to emotion is. Does that make sense? They're saying, how dare you come to any conclusion other than me? Think of the children. Think of the children, right? But that's not what appeal to emotion is. Well, let's look at it. The argument does prove that humans kill unarmed people. Well, that just doesn't seem is it that makes this argument an appeal to emotion? They're trying to use your emotional reaction to the statement, the premise, so that you get led to the conclusion. When there may be other considerations. Okay, so it's not that by force of logic you're compelled to believe the conclusion. It's that by appealing to your emotion, they say, come on, think of the children. Go and let's ban guns. Okay? I'm not saying there's anything wrong with banning guns. I'm not saying it's right. I'm not saying anything about that. I'm just saying that the form of the argument, the structure is appeal to emotion. They're trying to appeal to your emotional sensibilities to get you to come to that conclusion. And that is a fallacy. You can't just, it's good to set up some of your premises based on your emotions. There's nothing wrong with that. But logical conclusions to data that's given to you, drawing conclusions to those based off of emotion, instead of logic from the data, that's a different thing. That's a fallacy. Okay? You say that you're logically justified in the event. It's not through logic. Okay, so that's that one. We can see. Now, I'm not sure if I answered this one here. The conclusion was some things sale guns, and this one is the motion statement. Okay, the last question, part C. I feel like I answered 3 things already. Okay, so A had 2 secret questions in it, and then B and then C, so it's a 4-part question. Okay, so make up another argument that exhibits the same fallacy. Okay, so what we need to do here is read through the options and see which one of them is an argument that uses appeal to emotion. So it uses a fallacy in the argument. In your exam, again, I'm not putting a bunch of multiple choice things there for you. I think in the context of these types of questions, that's one of the things. I'll just ask you to come up with an example, make up an example for the type of fallacy that I gave you in the question. So you just write down a simple argument, exhibiting that type of fallacy. Okay. So let's see what they come up with here. So for appeal to emotion, remember we're looking for appeal to emotion, where the argument is trying to get you to accept the conclusion from the premise just based off of emotion and not because of logic. Okay, so let's go what they say. Option A is if a family owns a dog, they cannot also own a cat. I don't know how that's supposed to make me have any sort of emotional response, so that's not the answer. Does that make sense?
Mm-hmm.
They're not getting me to accept something because of emotion. They're not setting me up for having an emotional response. It snowed yesterday, so global warming is real. Yeah, I don't know. That's also difficult to respond to. It's difficult to respond to. It snowed yesterday. So first of all, think about what the premise is. The premise here is it snowed yesterday. So give you the data point. And their conclusion is global warming isn't real. Okay, but in an appeal to emotion, you set up a premise that gets an emotional response. And you hope that that leads a person to believe in your conclusion because of the emotion. Now, it snowed yesterday is not going to give me an emotional response. So this argument is not using appeal to emotion. Okay, it's not. So that one, I would call that a hasty generalization. We're talking about the premises that we talked about. A hasty generalization is you have one or more data points that correlate a couple of phenomena, and you say, oh, well, therefore this one causes that, or they're always correlated. So this would be hasty generalization. It snowed yesterday. Well, it has to be cold to snow, so the world's not warming up. Every day it's cold. That's the generalization of that. See, so that is a fallacy. That's different. See, more people have cats than fish, so fish must be a more exclusive pet. Well, again, the question is it appeal to emotion? So look at the premise for that. The premise is more people have cats than fish. That's data being provided to you. That's one of your premises. That, I don't see any reason why somebody should get an emotional response to that. And unless people hate cats and love fish, maybe then they're just pissed off. I don't know. But I mean, it sounds more like a person who just hates interacting with people than a normal person who gets angry when children are killed. right? So the first argument is an appeal to emotion because it's an expected reaction that people have an emotional reaction to something bad like children getting hurt. Yeah.
So it can't be that.
So it's going to be, let's think about it. If you want to pass this class, you should study. I can tell you from my experience that a lot of people in this class and others, and a lot of the math classes, do get emotional about passing the class. There's a reason to have an emotional response. Like you want to get this stuff behind you. You want to get it in the past. You want to move on with your life.
It seems kind of confusing to me, I guess, because it seems more like a person aspect of anything. But I understand
It
that.
can be. No, it absolutely can be. It really can be. So what he said is that it's a little bit confusing because it seems like a personal aspect of it. But that's absolutely true. Yeah, that's absolutely true. This appeal to emotion thing, it's not effective for many people for a couple of reasons. One is you don't get to the conclusion through logic. And that's what it means to be a fallacy. It doesn't mean you don't have a good point. You may have a good point, but it's saying that you don't get to the conclusion based off of logic alone. And that's the idea of a fallacy. And appeal to emotion, it doesn't work for a couple of reasons. A lot of people simply spot that and say, that's not why I should get to this conclusion. It's not based off of that emotional reaction. I have to think of more factors. I have to think of more data, more information. But for some people, it doesn't because they just don't have that emotional reaction. That's another thing. I guarantee you, this is sad, but I guarantee you there are some people who simply don't care that children are being killed by firearms. That's a real thing. And they're not going to be moved because they're not moved. They're not moved, so they're not going to be moved into the conclusion. But yeah, you have a point. It is a little bit difficult. And in some of these, it is a little bit hazy what the real answer is. So, so yeah, this is an interesting case of if the fallacy, it's a little bit. I think that it's fairly clear this answer, honestly, but I can understand being confused by it. But if you're confused by it, you might get worried about your performance on the exam because the example might be confusing. And then you could argue against the exam, and that would be an appeal to emotion. Right? It would be an appeal to emotion because you care about the performance on the exam. But I don't know. I'm doing circuit research. I'm playing it. I'm not making fun of it. I'm playing it. But yeah, I do agree. These things aren't actually completely clear cut. But that's another reason why you should just write things out in your case. The grading is going to be based on you can make a case. But yeah, I would say this is the best answer here. For the simple reason in this case, that none of these others do I find it very likely at all that people are going to have an emotional reaction to the premise. Yeah. And by the way, it's not going to be appeal to emotion. That's not going to be the fallacy in your exam. It's going to be one of the several others that we study. So look in the textbook. You can see a list of them and examples for all of them and things. There are several, but it will be clear. It will be clear what the idea is of the fallacy, what it means. Even if you haven't memorized that list, it will be clear what it means, and you will see from context, and you can make your example, and you can make your case.
So they won't. Okay. That's because like it's on the home list. Some of these examples. So.
I agree with you. Yes. I agree with you. I don't answer all these correctly. That's okay. That's not going to be a big deal. That's not going to be a big deal, especially when you get to write your own information. So, all right. So here's the second question. So this is talking about the fallacy of division. So this is telling you how the fallacy of division works. So it works in this format. The premise X has some property. So this object I'm talking about has some property. And then the conclusion is all things that belong to X must have the same property. Okay, so say that if you are in some class, there's some identifying characteristic of you, then you have this trait. If you're in that set of people, you have this trait. If you're in that set of objects, you have this trait. Okay, that's what that is. Fallacy of division. That you were in this class, so therefore you have this Yeah, that's fine. Either one is fine. I had to convince myself that I wasn't saying somebody's from the moon of Jupiter. Europa. Yeah, yeah. European, that's fine, because it would be European. Okay, sorry, it's just I want to make sure I'm either Europeans or Europeans. So Americans use more gasoline than Europeans. So Jake, who is American, must use more gasoline than Europeans. So can you see why this has the fallacy of division? Does anyone want to describe to me why it's the case that this is fallacy of division, please? Jake would be 3 weeks old, right?
Yeah.
He's 3 years old, doesn't have a car, doesn't do anything to do with gasoline. So yeah, but it's saying that because he falls in this category of American, and because as a general statement, Americans use more gasoline than Europeans, then Jake must use more gasoline than Europeans. Okay, so it's the idea, what it's called the fallacy of division is you're dividing people into categories, and this category has this property. If you're in that category, you have this property. It's a sign of that, but that's not actually true. Because look, Americans use more gasoline than Europeans. Now, you could interpret that statement as meaning every single thing that is in America uses more gasoline than every single thing that is in European. Right? I say thing, but I mean people. Every single person who is American uses more gasoline than every single person who is European. You could interpret that, but that's clearly not what's meant. That data point, that's not what they mean by that. They're meaning that in general, Americans use more than in general Europeans use. And so then, if you just say that you're in this category, does not mean logically that you necessarily have that property to use more than Europeans. So the first question here, and maybe it's the only question I wish, but no, explain why the fallacy, you can put this up. Explain why the fallacy applies to the example. So if you want to choose correct.
I have a question. Sure. So will it be like 6, 7 part questions like this?
No.
Okay.
No, this is just to prepare you. This is to give you all the skills. Mine is not going to have the multiple choice stuff at all. What I'll do is for this question, I do have one line this one example. So me is I define the fallacy for you, just like they did. They define it, and then I give an example and say, explain why this is that. Just 2 words. That's it. And so a lot of these have more parts than I actually do.
Okay.
So it should be easy. This one I designed it to be also longer than the exam. I think if I remember it was, I think it's maybe 90 minutes. I think it is suggested as the expected amount of time for a student to do this. And our exam is not 90 minutes long, 75 minutes long. So let's look at the example. So Americans have some property which is using more gasoline than Europeans. Therefore, Jake must have the same property using more gasoline than Europeans. Well, I mean, let's read the other options here. An American Jake uses more gasoline than Europeans, so does every other American on Earth. Jake is not European, so he uses a lot of gasoline. and X is the amount of gasoline used, and Jake uses a lot of gasoline because he's American. I don't know, that last one's really funny to me. There was an X up here in the description, so that's why they had the X there. I think that's pretty funny. So, I don't know, that's actually quite amazing. So it's not the X is the amount of gasoline used because they're not telling me that X is the amount of gasoline used. It's not C, Jake is not European, so he uses a lot of gasoline. Okay, because it's not saying that Jake is not European, it's saying that Jake is American and then concluding something from that. And just being not European wouldn't necessarily mean that American, it's not all one or the other. So it's not that. In American, Jake uses more gasoline than Europeans, so is every other American on Earth. I don't take that as an explanation for why the fallacy applies. First of all, it's asserting that Jake uses more gasoline than Europeans, which is the conclusion. And I think if you accept that argument, then it would be the case that every other American on Earth does as well, if that logic applies. But I think the thing that is saying why is fallacy of division is A, that Americans have some property. That property is using more gasoline than Europeans. And therefore they must have the same property. That's what the fallacy of division is. The fallacy of division, look at the form of here, division explanation, is here's a class that has some property. Then you conclude that everything that belongs to that class has that property. If you reread A in that context, here's what it says. Americans have property. X has some property. Okay, now it describes what that property is. Okay, but that's just because that explanation was given as the premise in the argument. And then it's saying the conclusion should be that Jake must have the same property. That means something that belongs to X has that property. So the format of this statement is telling me that it's looking at premise and conclusion here from the definition of division. Fallacy of division. So the answer is that. Confidence answers that. Yours again won't be quite as confusing as this with the options. It's going to be just explain why. And so you would have to write something like, oh, look, it's saying that Americans have some property and Jake is American. And so the argument of fallacy of division would conclude, you would conclude that Jake has that property. It is more confusing, I think, with the multiple choice. And then it asks you to create an argument that uses the same fallacy. So let's look at these arguments and see which one that we describe as having the fallacy of division. So remember, the key things to look for fallacy of division is you're claiming that some class has some property. Then you're saying, here's a member of that class. So it has that property. It has that property. So let's look at an example. So the average person eats 5 spiders in their lifetime. George is a person that eats more than 5 spiders. Well, that's not the fallacy of division because you're not getting the conclusion that because he's a person, he's eating 5 spiders in his lifetime. You're not getting that conclusion. So it's not for that reason. It's just not for that form. How about your neighbor's pet goose weighs 5 kilograms? So all geese must weigh 5 kilograms. That's exactly the opposite of division. That would be some generalization. I might call that a case of generalization. Here's an example of a goose that weighs 5 kilograms. Oh, I guess geese weigh 5 kilograms. Right? So that's not the format of division because we're not starting with a premise that is of this form. Objects of this class have this property. That's unique. So we need to look for that. C, the average cow weighs about 500 kilograms, or 1,500 pounds. Now that's the form we're looking for. You have a class. The class is cow, and then it's giving you what property the average cow has. Members of the class have 1,500 pounds. And then, so a young cow must also weigh 1,500 pounds. Well, a young cow is a cow. It's in that class. The class of cows. So this is actually the format. So the answer is C, but let's look at D anyway. The average high school student spends 3 hours on homework per night. Okay, well that's also this format. Me as a high school student who spends less than 3 hours on homework per night. Almost, but this is kind of like the first one. If it were fallacy of division, then the fact that he's a high school student would be used to say that he spends 3 hours on homework. See, the fallacy of division is state a class has a property, state say something is of that class, so it has that property. And A and B are almost that. They're saying, here's some class that has a property. Here's an object in that class that does not have a property. Okay, so that's not valid subdivision. So the answer is C. If somebody tried to convince you that a young cow has to weigh 1,500 pounds because the average cow weighs 1,500 pounds, that would be valid subdivision. Okay, so you will have this question exactly the same on the exam. This exact question will be on the exam. So good reason to pay attention for this one. It's actually going to be on the exam. I didn't have a decent substitute for this one. I wanted to have something with truth tables. I didn't have a way of making it fair and more complicated or anything like that. So it's going to be exactly the same, just not in the multiple choice thing. It's just here's the truth table complete. Okay, so this is saying complete the truth table for and. Okay, so here you have a statement P and Q, these are propositions, and you have their truth values listed below, all possible combinations, and you're supposed to figure out which over here are true and which are false. Yes? Yeah, so this is very easy. We're asking, when is the case that P and Q are both true? Well, only on the top one, they're both true. So this is true, and the others you have at least one false, so they're not both true, so false, false, false. Well, they randomize the appearance of true and false. That's the option. Okay, so then it asks you to explain. You don't have an explain part for your question on the exam. It says explicitly in the question, you don't need to explain this question. It says it in the question itself. But let's do it here. When is P and Q true? So which of the options here is true? Or can you just describe it? When is the statement P and Q true? Yeah. I tried to put my hand up so that. Yeah, it's A. It's A, that's right. So P and Q is true when P and Q are both true. And not when either of them is false. Either or both are false. So the explanation is when P and Q are true, when both P and Q are true. Okay, very easy question. I hope it remains easy on your exam. Same question should remain easy. Now, how about for P or Q? This one actually is tougher. When we say P or Q in logic, we simply make a choice of whether we need inclusive or exclusive.
This won't be on our exam.
Yeah, this one will be. It's all in one table on your exam. I'll tell you exactly how to look. It's P, Q, P and Q, Q or Q, and one last column, which is if P is not. And that's how it is. Yeah, it's true, false. We use, just by a choice, it's just by standard, we use inclusive or for the or in logic. And inclusive or means when you say this or this, that's true if either one of them or both are true. The exclusive or is the one where you mean specifically only one of them is true, exactly one of them is true. People do that sometimes in common speech, like, I will go to the store or I will go to the gym. Often when we hear somebody say something like that, they mean, okay, I'm only going to do one of those two, I'm not doing both. So that's an exclusive. But to make it easier to write things down, and make it easier for us to use symbols and stuff for math, we just make a standard choice for us to be able to write things down. It's like the order of operations, if you remember that from elementary school. The order of operations, why do you do the PEMDAS thing, parentheses, we just have to make a choice. We have to make a choice so that when we write down symbols, people know what we mean. And there's no importance to it. It's just we make a standard and we stick to it so that we'll communicate with each other. And so that's what we're doing here. We make it inclusive. Okay? And then the last one here it says, explain why. Okay, so this one actually says, select all that apply. This is actually more interesting. P or Q is true and P is true and Q is false. That's correct, because at least one of them is true. P or Q is true when P is false and Q is true. That's also true because at least one of them is true. P or Q is true when both P and Q are true. Yes, because this is inclusive, or we mean at least one of them is true. The last one is not a correct statement. P or Q is true when both P and Q are false. Mean at least one of them is true. So that's a false statement. Okay, here's this last one. This is also one of the exam. The if, P, and Q table. Yes. True, false, true, true. That's absolutely correct. This one is also something that has a convention built into it. And so I can explain the convention to you. We say that an if P, then Q statement is true. If you're not lying about a promise. You think about it this way. Think about it as this. I promise you, if the condition P is met, then Q is true. If I'm communicating, it's like I promise. If P is a true statement, then Q is a true statement. If P turns out to not be a true statement, then I'm not promising you anything. Right? I'm only promising you under the condition that P is true. And so if P is not true, then I'm not lying to you. So the example I gave in class was, if the moon is made of cheese, then I will give you $1 million. Okay, and that's a true statement. I guarantee you, if the moon is made of cheese, I will give you $1 million. But the moon's not made of cheese, so I'm not obligated to do anything. I'm not lying. I'm not lying. I'm still telling you the truth. Does that make sense? So we choose that as a standard. We didn't have to do that. We could have chosen something else. But we chose this because it's easier to make statements this way. It's just easier to write down our theorems, our math things. And so that means that whenever the P part, that's the condition, the hypothesis is called P. If it's not true, your statement is automatically true because the condition of your promise is not fulfilled. So you're not obligated to do anything. Okay, so if the P part is false, it's automatically a true statement. But if the P part is true, your statement is that whenever P is true, Q is true. So Q has to be true also. So the only way for a conditional statement like this to be false is if the if part is true, but the then part is false. That means you lie. If the moon were actually cheese, that I refuse to pay you $1 million, then I would lie. That's the one way I would lie to you with that promise. Okay, so that's the only way that an if-then statement is false. And then we have one last question. Select all that apply here. If P then Q is true when both P and Q are true, that's correct. If P then Q is true when both P and Q are false, that's also correct because if P is false, it's a true statement. If P then Q is true when P is true and Q is false, no. That's the one time you're lying. If the moon were made of cheese and I refused to pay you $1 million, I would have lied to you. If P then Q is true and P is false and Q is true, yeah, that's absolutely the case because the condition for your promise was not met. So it doesn't matter whether the other statement is true or false. The condition wasn't met, so your statement isn't lying. All right, let's continue. I need to pick up the speed here so I can get to the more complicated questions later on. Carrots or mangoes are round. Okay, this is a statement of the form P or Q. Carrots or mangoes are round. So what is the statement P? What would you say on these options? Carrots are round, or round, yes. Carrots are round. That's the statement P. Another way of saying carrots or mangoes are round is carrots are round or mangoes are round. Okay, so that's the P. Q is going to be mangoes are round. Right? And now, what do you say about the statement? Is it true? Carrots or mangoes are round? What would you say? how round, it's round, but that's a true statement. Carrots are round. Well, I would say no. Is P true or false? I would say no. It's false. Is Q? I would say yes. And so then it's asking, is the disjunction true? Disjunction is the name of an or statement. That's what they're called disjunctions. So what do you say? The or statement. Carrots or mangoes around. What do you say? True or false? It's true. It's true because at least one of them is true. The statement is true because the first proposition is false and the second proposition is true. Okay, so it's because of reasoning. Okay. So hopefully not too bad. Okay, so here's another one. This is about implication statements. So again, this is about the formal logic stuff we discussed in section B. We have a statement here. If Teresa works in Vermont, then she works in the North. Okay, that's a conditional statement. A conditional statement. If-then statement. And remember, for if-then statements, we have a lot of ways of transforming that into new statements. One of them is the converse. The converse is when you just switch the if and the then. Another one is the inverse. That's where you just make both the if and then the opposite. So not. You apply not to both. And then there's the contrapositive. That's when you both switch the order and make them both have not. That's contrapositive. Okay? And so let's look at each of these. So identify the converse of this statement. So which one of them, A, B, C, or D, would you say is the converse of this statement? Wow, why is it not allowed to be wrong anymore? Anyway, I'm sorry, go ahead. Please. D, if Teresa works in the North, then she works in Vermont. That is the converse. Remember, converse is you're just switching your P and your Q. That's all you're doing, converse. It's like converse secrets. You're just switching your feet. Right? You're just switching, not turning them upside down, walking on top. Right? You're just switching your feet. I don't know, I just made that up. I was like, okay, what can you do to remember the word converse? There you go. Maybe that'll stick in your memory. Yes?
Is this test be electronically or?
No, it won't be. It's paper. It's paper. You'll actually just write things out. It's not going to be a bunch of multiple choice things. Just straight questions. You can write things. Some of the questions will say explain something like. So I don't know. It's kind of a midway between math exam and English exam in a way. You're going to have some writing. It's not like essay questions exactly. You just write something out that describes what you mean. That's what. So you're right. It's D. Now the inverse. Do you remember what the inverse is? Yes.
The original conditional type not.
Yeah, have a not on both the P and the Q. So if your conditional is if P then Q, your inverse is if not P then not Q. Yes. Oh, okay, sorry. Sorry. So that would be if Teresa does not work in Vermont, then she does not work in Vermont. Again, that's D. Okay, so that's the inverse. Now the next one, what's the contrapositive? So the contrapositive is when you both switch the order and you put knots on both. Okay, so for us, what's that going to be? Which statement is it going to be? Please, go ahead. C, if Teresa does not work in the North, so you just take the second one first. So if she does not work in the North, I'm sorry, right here. If she does not work in the North, you negate it. Then the opposite of this one, then she does not work in Vermont. Okay, so if Teresa does not work in the North, then she does not work in Vermont. That's the contrapositive. And then a last question, we want to select all the pairs of these four different types of statements. The conditional, that's the if, P, then Q. The converse of the conditional, which is if Q, then P. The inverse, which is if not P, then not Q. And the contrapositive, which is if not Q, then not P. These pair up. There are two of them that are equivalent that mean the same thing, and another two that are equivalent that mean the same thing. conditional and contrapositive and converse and inverse. So, let's give them together. So I'm gonna say the conditional and the contrapositive. There's a statement up there. That's the conditional. If Teresa works in Vermont, then she works in the north. The contrapositive is, if Teresa does not work in the north, then she does not work in Vermont. And these things are logically equivalent. They actually do the exact same thing. If she works in Vermont, then she works in the north, because Vermont is in the north. If she does not work in the north, then she does not work in Vermont, because what? Vermont's in the north. They mean the same thing. And the other one, the converse and inverse. The converse is, if Teresa works in the north, then she works in Vermont. And that has the same meaning as, if Teresa does not work in Vermont, then she does not work in the north. It's tougher to reason through that, but those have the same meaning. Okay, if you get a truth table studies, you find that you have the same truth values for them, no matter what it is. Okay. Okay, so here's a categorical proposition. So when you see the word categorical proposition, this is bringing us into section 1C, which is on Venn diagrams, and using those for logic arguments. When you're talking about statements that have to do with sets of objects, and you say some of these sets have this property, or all of this set has a property, or none of this set has a property, if you're making statements like that, you can draw a Venn diagram that shows how that set relates to these other sets, the properties that you're talking about. And then you can identify and have a visual map of that fact that you're talking about. Okay, so here we have the situation, dogs don't meow. Is it possible that some things that meow are dogs? That's the question. So whenever you see this, there are a couple of things that you can do. One is you can rephrase it into something that has more words, because we're used to talking about sets where we have things, statements such as this: some of this class or some of this object has this property. None of this type of object has this property. Or all of this type of object has this property. So it's useful to change the language a little bit to put it in that sort of context. And then once you do that, you need to come up with sets of relevant objects, so that you can see the relationships with the Venn diagram. Okay, so the first question here says, rephrase the statement in some standard form. So it's also asking, do you need to rephrase it? Well, dogs don't meow is not in a standard form, because the standard form has these keywords in it, like all, or none, or some. Yes? So the answer is B. Yes, that's right. B is right. Yes, the standard form is no dogs or things that meow. Okay, when you have no or none of this class, then that's in the standard form, and it tells you something about how to build a Venn diagram. So that's correct. Now it asks us to get subject and predicate sets. Okay, I'm not going to ask you in the exam or find subject and predicate sets. I'll say you have define the sets that are relevant and draw a Venn diagram for this categorical proposition. That's the entire question. Okay, this just breaks it down into a bunch of parts. But what would you say the subject and predicate sets are in this case? So think of the statement you see right here. No dogs or things that meow. So what would you say is the subject set? Subject in this case means you have a sentence, it has a subject and a predicate. So what is the noun and the subject? Yes, please.
Dogs are pets.
Dogs. So we name it S. That was their standard in the book. Naming the subject set S. And then the predicate set are going to be what? And go ahead. Things that meow. Things that meow. I think you should get paid to teach this course. So dogs and things that meow. So yeah. So the subject set S is going to be dogs. The predicate set is going to be things that meow. So we can answer both of those. The dogs set is S because it's the subject of the sentence. That's actually the reason. That's the reason. Which says the predicate set. So when it says no dogs meow, see, look, we figured out that logically, dogs don't meow is the same as no dogs are things that meow. Now that we have that, no dogs, so that's our no S, right? None of our subjects said S. None of them are P. None of them are things in our predicates, things that meow. None of them. So what does our Venn diagram look like? Well,
Are the two sets separate?
two sets separate. They are disjoint. That's the technical term. Disjoint. They have no elements in common. So you just draw them separate. And so of these three options, this is the only one that's reasonable. Okay? The dogs are over here. They're not among things that meow. None of them. There's nothing that's a dog and something that meows. So they're completely separate sets. Okay? And then one last question. Based on the Venn diagram and the proposition, can you conclude that some things that meow are dogs? Is that possible? What would it mean if some things that meow are dogs? That's correct. So there's no overlap between the two sets. They're disjoint. The answer has to be C. They don't intersect in any way, those sets. If it were the case that some things that meow are dogs, then there have to be a part of the circle for some things that meow, and inside the circle for things that are dogs. But they don't. They're separate. So it's not possible. That's the answer. Again, this is more complicated than your exam. I'm making it simpler questions than this, but it seems this is a lot of work. This is a lot of work. You have 8 regions and 3 overlapping circles in the Venn diagram. You're supposed to draw it and describe the members of each region or state that the region has no members. And the categories you have are words that begin with I, verbs, and words that begin with 4 letters. And so then we have to look at the different Venn diagrams and see which one is correct for this question. So we have to click all this stuff, and I wonder if it'll even show up on this screen. So you can see they have 3 sets labeled as verbs, fewer than 4 letters, and begins with I. So far, so good. Yes? See, look at this. Universal set, no members. Good point. She says that we can ignore this because the universal set, that's the box. That's the universe of all the things you're talking about. In this case, we're talking about words. So this is all words. And so if there are no members outside of these 3 circles, it's saying that there are no words that fail to have all 3 properties of being a verb and fewer than 4 letters and begins with I. So that's saying there that every word in English is either a verb or it has fewer than 4 letters or it begins with I. That's not true. So this is not the correct one. What do they do with this? Venn diagram A, Venn diagram C, Venn diagram B, Venn diagram D. That's kind of absurd. Anyway, same setup. So let's see if the description is correct. Inside of here, this region of the circle should be things that are verbs, but that are not having the property of fewer than 4 letters, and do not have the property that begins with I. And that's correct. It's verbs with 4 more letters that do not begin with I. In here, this little line is pointing to this region that's sort of a curvy triangle shape. It's inside of the circle for things that are verbs and fewer than 4 letters, but it's outside of the circle of things that begin with I. So look at the description. Verbs, fewer than 4 letters, do not begin with I. That's correct. That's what that would represent. This little arrow is not the right one. This little line segment is connecting us to the region that's only inside of the fewer than 4 letter circle, outside of the verbs and outside of the begins with I. So this is saying not verbs, fewer than 4 letters, do not begin with I. That's correct. This center curvy triangle region is inside of all 3 circles. So it's verbs with fewer than 4 letters that begin with I. This other triangular shaped region here, that's inside the circle for verbs. It's outside the circle of fewer than 4 letters, so it is 4 or more letters. And it's inside the circle for begins with I, so they begin with I. other triangular shape region here, it's outside of the circle first, so not verbs. It's inside of the circle for fewer than 4 letters, fewer than 4 letters, and it's inside of the circle for begins with I. So that's good so far. 2 last ones to check. This one is only inside the begins with I circle. It's outside of the verbs and outside of the 4 few letters. So this is a correct description. And then this region, which is outside of all 3 circles, you need to not have any of those 3 properties. So they need to not be verbs, 4 more letters to come from I. So that's correct. So Venn diagram, so this is, so option B, Venn diagram C, that's the correct option. I don't know why I do this for randomizing the letters, but it's just but that's the one. And so I do have a question on your exam like this. It's not with options, a bunch of pictures that I give you the picture, and you can draw little lines like that if you want, but try to give it a very brief description of what the items are of each of those ABCs, so that you know how to use it right. Okay. So you will have one like that in the exam. It's a very big picture too, so you should have enough room to give very small descriptions, short descriptions. And remember, I also stated in the problem, there are 8 regions. There are 8 regions in here. You have to involve. Okay, this question is on validity and soundness. Okay, so who remembers what vowel are? Yes, you justify the conclusion from the premises by logic. That it necessarily does follow from logic if the premises are true. That's the validity argument. It doesn't mean that the result is correct, but it means that what it does mean is if the premises are correct, then the result is correct. It is that right? The result is correct. If the premise is correct, it must follow. So it's saying the logical structure of the argument. That's the meaning of a valid argument. It's valid if, by virtue of logic, if the premises holds, the conclusion must hold. That's what validity means. Soundness, what does it mean? You might tell me what soundness means. Yeah, that's right. A sound argument is one that is both valid and the premises are true. So if the premises are correct and it's a valid argument, then you can actually trust it to be correct. And that's what means for argument to be sound. So what you want, this is something that's a sound argument. That's what you want. That's what it takes. An argument can be valid, but you could be lied to in some premise, and then you can't trust it. It's not sound. Does that make sense? So to be sound, you must be valid, and the premises have to be true. That's what it means for being sound. So this one is saying which of the following clearly or correctly explains the idea of validity. And so which one is it? B, the deductive argument is valid, its conclusion follows necessarily from its premises. Okay, so those are words exactly. That's exactly what it means for an argument to be valid. How about soundness? Yes. It is the deductive argument is sound, which follows necessarily from its premises. I think it's valid. And the premises are true. And the premises are true. So that means the end. So then before we see the options here, can a valid deductive argument be unsound? Is that possible? Yes, absolutely. Absolutely. Let me give you an example of a valid argument that's unsound. If you are a basketball player, all basketball players are over 7 feet tall. Anderson is a basketball player. Therefore, Anderson is over 7 feet tall. That's a valid argument. It's a valid argument. It's not unsound. So this one is, yes, let's see why. Yes, since the argument's conclusion can follow necessarily from its premises without the premises being true. And that is, that's correct. The other yes here is saying something nonsensical. Yes, since the argument's conclusion could be true without it necessarily following from the premises. It's possible to have an argument that the conclusion is true without it following from the premises, but that's not what it means for it to be valid and unsound. That's not the answer to this question. And then the last question for this question is, can a sound deductive argument be invalid? So we say no. The answer is no. Part of the definition of being sound is that the logic works, that it's valid. To be a sound argument, you have to be valid and the premises have to be true. So sound implies valid. So that's the answer of no. Okay. If I'm ever going too fast or you have questions about this stuff, please stop and ask me. Okay, here is an argument with categorical propositions, and it gives you in this format, it spells out what the premises are and concludes them. So the first premise is all case study. And the second premise is little cavern is a cave. And then the conclusion is little cavern is deep. We're to determine whether the argument is sound, but also discuss whether the argument is valid. And of course, if there's a disparity there, it's going to have to do with the truth of the premises. Okay, so the first part of it says, let X represent little cavern in the diagram. So that means the X is pointing to where is the case that, according to the argument, where is the case that little cavern lies? Okay, and so the first thing to notice, yes, please. Yeah, it is. You're jumping to the answer. I wanted to work my way there. The first thing. So all K's are deep. So all K's are deep. That's saying that anything that is a cave is something that is deep. So that's the categorical proposition. You can separate it into a subject and a predicate, and there are sets there, caves and things that are deep. And so saying that all caves are things that are deep, that's saying that the set of caves, your subject set, and it's just labeled caves here, it's saying that it's inside of the set of things that are deep. Now, all four of the options, they've already gotten to that point. They've already done that analysis. They have the Venn diagram like that. Where caves, the set of caves is inside the set of things that are deep. But then it's asking where you put X. X is representing little cavern. Well, the second premise tells you that little cavern is a cave, so that X belongs inside the set of caves. Okay, so they put the X inside the cave. That's why it's B. That's why B is the correct answer. And the others, they have the X as